Thank you for inviting us. And my name is Pradyumna Das, and from the part of the world where I'm coming from, I'm from India, so we generally give a very long name. And over the time, we just chop it up, and now I settle down with Paddy, so you can call me Paddy, which is easy, simple, and nice. So I work as a solutions architect for Amazon Web Services. Today we are going to talk about big data analytics using AWS. We'll be giving some examples of use cases and what we, what services we offer. Yeah, okay. So how many of you know AWS, and how many of you are actually working on AWS in show of hands? Cool. How many of you know Amazon? Quite a number. Okay, so my background is more like 10 years, 10, 12 years. I've been into development, DevOps, and infrastructure and cloud computing, and I joined Amazon Web Services more than a year back. I love this slide. These guys came up with a slide saying that the online book and decorative pillow seller, Amazon.com, started something on cloud, right? So we do definitely do a lot of interesting things, and cloud is definitely one of it. We started in 2006, and we were pretty good at in the left-hand side, the brown boxes. To make it work, we had to have our infrastructure ready, right? So after a decade of managing, maintaining, building Amazon.com's web platform, we realized that there is a pain outside Amazon.com as well, because people are investing a lot in terms of the data center, managing that scalable infrastructure is the problem. There's a lot of investment. So so we started giving those resources back to the customers, right, through APIs and through different services. So that is how AWS formed, and it's one of the well-known cloud computing companies in the world. We have got, we'll talk a bit on the regions. So we have got 16 regions, 42 availability zones, and 76 edge locations. What exactly a region means? It's a geographical location where you are storing your data. So think about Europe. In Europe, we have got 3 regions at this point of time. One in Frankfurt, one in Ireland, and the other one is in London. And we are adding more and more regions. So we have just announced 3 more regions. One in France, one in Stockholm, the other one in China. What does that give is that the data compliance. So if you are storing your data in UK, nobody's moving your data out of UK, right? So you're complying to the UK policies and the security requirements. Each region consists of area of availability zones. What availability zone is, it's equivalent to data centers. Each availability zone has got multiple data centers connected with each other with a redundant power supply, redundant grid, and we take care of the high availability of those infrastructures, on which the availability zones are built upon. Just giving you a scale, each of the data center has got minimum 50 to 80,000 servers. And we have got 76 edge locations. Edge locations are the POP locations where you can store your data contained in videos and stuff. Security is a number one concern for us as well. Like, we take security very as a priority of the business. So as I told that we cannot see your data, because every time you do something on AWS, you are giving a private key, and the key is with you. If you lose your private key, we cannot help you out, because it's your data, and we encrypt, you are encrypting your own data. We follow something called a shared responsibility model, whereas we take care of what is till the hypervisor layer, and from the hypervisor layer up, like operating system, application, etc., is the customer's responsibility. Apart from that, we have gotten a lot of key certifications. You can go to the AWS site and check, how many, there are a number of security certifications, and for UK it's 27001, 27017, 18, PCI, and all those certifications. You can also go ahead and download it through some NDAs. Apart from these industry certifications, we also give you some tools. So encrypting the data at rest, encrypting the data at move, and DDoS or web application firewall, etc. Right? So you can use those. We have 1 million active customers across 190 countries, and so it is just that, like, we just picked out some of the use cases or the customer use cases. So customers like UCAS or TFL or MOJ or DVLA all are running on top of AWS. So if you look at UCAS on the results day, they really get a high number of logins on their website, right? To maintain that spike, if they would have designed in their own data center, which they have done it in 2011, 2012, they had a massive problem, right? I mean, this website was down. So to look at how they can be scalable and agile and cost efficient at the same point of time, they run the infrastructure on AWS. So today, on the results day, there's a team of AWS, goes there, help them out as well. But at the end of the day, 364 days, or apart from that, A-level results day, all of the time they are running on a scalable infrastructure. They have never planned for the for that particular day. They never planned for the hours. Right? Same for the TFL as well. We'll talk about TFL, and like MOJ just migrated their data centers to AWS, and they are running heavily on top of AWS. Big data and smart cities. The cloud was built for big data. So agility is one of the drivers. Why? Because innovation, like everybody trying to innovate, right, on something. Now innovation has got a lot of, so you need to iterate multiple things to innovate, right? And that iteration, it might be a failure, right? And failure is expensive, right? But by using cloud, what happens is you are just using mail for an hour, it doesn't work, you can throw it out, go ahead and consume something else and do on the top. So agility is one of the major points why customers are looking at cloud as the default new normal. We have got more than 90 services now, whether that's storage, servers, or network, or big data, analytics, AI, machine learning. Like you can just name it. So if you look at the service map, it's just like a Lego. You can pull those services and build on the top, right? Whether that's a big data application or just a database or just some kind of application you are building on top of AWS. Scalability, scalable infrastructure. So it provision infrastructure based on the demand. If there are example 10 users, I might have got 2 servers. If I have got 1,000 users, that 2 servers will be auto scaled to maybe 20 servers, right? So that is the scalability, and you are just paying for that particular time, right? You are not designing your infrastructure for the worst, which is currently today you are doing it, right, on the data centers. Low cost, so cost is another driver. So we give you a lot of options from smaller instances to the bigger instances as well. And these days everybody talks about serverless, where there is no server at all. You just function as a code. You just bring your code, push it. We take care of all the underlying infrastructure. You don't need to create it. You don't need to maintain it. You just pay for number of interactions to the backend, right? That we call serverless, and we have got a service called AWS Lambda, which you can use for that. Data migration made easy, so you can actually move exabyte of data. So the data migration can be like you can actually get Snowball devices. So Snowball is a physical device which comes up with an 80 terabyte. So if you have, let's say, 400 terabyte, you can actually copy the data to the Snowball device and ship it back to AWS. We will copy it back. There are some customers, who might need petabyte of scale. So we last reInvent, we came up with something called a Snowmobile. Snowmobile is basically a truck, which comes up with 100 petabyte of scale of data. So you can actually get the truck and copy the data to the Snowmobile device and ship it back. And there are customers who are using it. So big data was made for cloud. Why is that? Because if you look at the characteristics of big data, it's all about velocity, variety, and volume. Iterative, experimental, because that is where the innovation comes in. You try something, you fail, and now that fail brings cost. right? If you commit on the traditional infrastructure on something, you have to tie up whether you are actually successful or failure. You have to tie it up to that particular software or hardware. In here, it just maybe an hourly cost you are paying, right? If something doesn't work, maybe after 6 hours you can throw it away and try something new. So that brings the innovation. Potentially massive data sets. The data sets massive can be petabyte or maybe more than that, right? Exabytes data. So all these characteristics of big data, it's solved by cloud computing, because cloud computing is agile. Cloud computing gives you a lot of choices. Computing, the cost is on demand, and you can build faster because the APIs are there, so you can build much more faster and quickly. What we offer in the big data platform, so these are the services. So this is some of the services, because we have got 90 plus services. So if you look at the left hand side, Direct Connect gives you the connectivity from your own data center to AWS. It gives you a dedicated 1 gig or 10 gig pipe, so you can copy the data across to AWS. Import Export is another method. Snowball I've spoken about. It's just a suitcase with a disk. It supports around 80 terabyte. You copy the data, ship it back to AWS, and we take care of that. IoT endpoints. So IoT endpoints, any sort of thing like telemetry data, or you would like to switch on, switch off a bulb by IoT button example. So all our IoT data based on MQTT or WebSockets, you can actually interact with Amazon Web Services. Kinesis has real-time data. You want to take I was talking to the ladies. She and her team does a lot of natural language processing on Twitter feeds, right? So those things are real-time data. You can use Kinesis Firehouse to stream the data to AWS and then build on the top of it. Database migration service, we have a service called DMS, which helps you to migrate from homogeneous to homogeneous and homogeneous to heterogeneous databases as well, right? So MySQL, say example, Oracle to MySQL or Oracle to PostgreSQL or something else. Like it supports all sort of database migrations. Lambda is serverless. So serverless in the sense. So think about it. It's like our data. You are sending it to AWS, and then you'd like to do some processing, right? So right now you might be spinning up servers, which is actually doing the processing. But if you have got something like Lambda, it is event driven. So once the data comes into somewhere to maybe a database or S3 bucket, etc., automatically your Lambda will be triggered, and it will do the processing and send the result back to somewhere. Now that somewhere can be a S3 bucket, or can be a database, or can be somewhere else, right? So this is serverless because you are just bringing a function, right? That underlying infrastructure, you don't see that. You never manage that. You are just bringing the code. That's it. Data pipeline is another service, and so that there are so many services. S3 is another one. S3 is the object store, which is to store the data. Customers use store all their data to S3, and from there you can put it for machine learning, can push it to Redshift like data warehouse projects, or can consume from S3 itself, right? So that's maybe a source of truth to keep everything there and do processing on the top. So data lake, how many of you have heard data lake? Yeah, so data lake, so keep all the data to S3, and from there you can start processing and looking at what kind of service you would like to consume the data in. Quickly, Glacier is archival solution. DynamoDB, NoSQL, Aurora is a database built by us, which is a cloud-ready database, which is scalable, which is massively it's cheap, it's cost-effective, and it's scalable. So by default it goes up to 64 terabyte without any intervention, right? So if you're storing today 20 gig, now tomorrow 80 gig, so automatically that storage layer extends, and there are a lot of other advantages as well. For analysis, you have got EMR, Redshift, the data warehouse product, Kinesis, Athena, which is released sometime back, QuickSight as well. So QuickSight, I think you are going for a demo today. So in a demo, so QuickSight is like Tableau, it's based on the Spice protocol, much more faster, quicker, and cost effective. And then we have got machine learning. If you have got machine learning, some models, you can use machine learning. And, yeah. that's more of the big data platform and what we offer. So they talk to each other because they talk to each other, right? So you can pick maybe a couple of from the left hand side and a couple from the right hand side and just plug, because they talk over APIs and they're connected with each other very well. So it depends what you need. We'll talk about a bit on the smart city. So smart city is not about IoT, just IoT. It's about the power of collecting the data from multiple sources, keep it somewhere, and then building on the top, right? So data sets can be citizen data, can be open data, and then can be sensor data, and you're pushing it to somewhere to a single source of truth, maybe an S3, maybe somewhere else, and then you are doing machine learning and data analytics, right? So you get the data, you find out certain points, build the model on the top, and then use it. This is one of the examples I picked up. So this is for the, I think, city of Boston. So we came up with a application called Street Bump. What does that do? It just takes the accelerometer and the GPS of phone. So when you drive, it just finds, okay, where there is a problem in the road, bumps on the road. Automatically the data goes to the central system and they find it, and then the inspector comes in and say, oh, this road needs to be fixed, so they go ahead and fix it, right? So that is how it works. So the data, sensors and analytics, and so you can, so from that particular data you can do a lot of other things as well, because at the end of the day data is there, you just need to find out what are the models you'd like to build up on. So this is great. In 1930s, 15 minutes. In 30s, this is how TfL staff used to find out the most popular route, so that they could invest in those, for the infrastructure, or the new tube and all that. But this is, so the model of software delivery has changed over the years. If I remember 10, 15 years back, if I had to install a software, I need to drive to a store, buy a desk, come back home, put it in my 3.5-inch floppy. Oh, I started in 5.5-inch floppy, and then to the desk and install it and configure it. But today, it's all about your phone, right? We get the data over phone. Everything is over the phone, and the accessibility, right? So to look how TfL has made that innovation. So they started this, so open data journey planner, which you can use it over the internet, from your phone. They're using the website and open data APIs. Now that open data API is also out, it is exposed outside as well, and based on that, developers are developing more and more innovative application on the top, right? So this is citizens data, your phone, as a citizen, you need those data to be available to you, and that is what TfL is doing, right? What happened after doing that? So if you look at the, so right now it's a 31 million journey per day, 600 apps and growing. So the startups are picking up, those open data and open data API and building the application on the top. So there are so many advantages to it, right? So the scalability, agility, innovation, all that brings in, because AWS Cloud is gives you that business value in terms of building and growing. Pace of innovation. 2016, we released around 1,017 product sets, and we are a customer-obsessed organization, right? So our product cycle or the product features are driven by you. You come up and say, okay, this is missing, we need this, and based on that, we work on. I think, 2016 is 2017 products. It's more than 90 plus services now. And this is for the AI, if you are interested in AI, Alexa, what's up, what's the weather, right? So all that based on Lex. So Lex is the engine inside Amazon Echo. How many of you using Amazon Echo? Anyone? Yeah. Okay. So Amazon Echo is a device, is a smart device based on AI, and the engine is Lex. You can talk to Amazon Echo. You can talk, like say, okay, play your music, or order me something from the internet, get me an Uber, switch on, switch off my lights. So all those things, powerful things you could do through Amazon Echo, and Lex is with the engine behind it. Recognition. And to be honest, it's just 2 clicks away to develop something like this, because the service is there. It's just a matter of clicking it and pushing the data into it, and then you can build on the top. And yeah, that's from what we offer and what we do. And because of the cost effectiveness, the agility, cloud has become the new normal now. People are innovating on the top of AWS cloud, because of the offering and the innovation which we are bringing to the table quite often. Thank you.